Hello and welcome back to SCI Teach. This is a physics practical video on force board experiment. So we're going to see how a force board looks like. Of course, it looks like this. It's set up here, and we'll see what we can use it to find like the moments. So I'll pull up a equation which we can use so that it will give us direction to start. All right. In the diagram, a thread AC fixed at pulley A passes over pulley C on a force board and carries an unknown mass m0. You have a thread, as you can see, and then it's the pulley on the left is fixed, and that's pulley A, and then a thread passes through that fixed pulley to pulley C, which is on your right, and that pulley C is not fixed. It can move, it can rotate, so it can allow the thread on it to adjust. That's what you're asked to do. And then we attach a mass m0 at the end of that thread. The mass m0 is not known, right? So it's unknown mass m0. Now we should maintain this position of m0. Don't move it, don't remove it, don't untie it throughout this experiment. Now we have to draw a line along the direction of AC on the paper held behind the thread. You'll see that in the video. Then locate the midpoint B of AC. If you look at that line AC, you'll see there is a B that goes vertically. That's the midpoint of AC. So we locate that we locate that point, that midpoint, and then draw BP. Draw that. When you locate that point, draw a vertical line that goes down, and the end you call it P. So that line is BP because the center of that AC is what you call B. So you draw BP at right angles to AC, and then by means of a loop of thread, that is, loop a thread on AC, attach another thread on the thread AC, but attach this thread in a way that it is not fixed. You can adjust it easily, like you're going to see in the video. That's the loop. So by means of loop of a thread, suspend a mass m equal to 50 gram from AC. So you can see in the diagram where you are seeing m, not m0, is the mass now. So we attach 50 gram mass to that point we're seeing m. All right. When we attach that, we adjust the position of the loop so that it stays so that the line of action of the weight of m lies along BP, so that it stays along BP. You will see it in the video. So that's what we're going to do now. This is m0. This is the m0. Now we are, as you can see very well, this is the line we drew. Okay, this is a 50 gram mass that we're going to use. All right, it's 50 gram mass we're going to use for a start. Remember, the m0 mass is unknown, so that will remain in that position till we finish the experiment. We have a mass hanger which we can hang on the thread that we looped from AC. All right, that's what we'll hang our load. So look at pulley A is fixed. The midpoint between AC is B, and pulley C is not fixed. Now we're going to use our mass hanger and try and hang a mass of 50 grams. But your own question will be different, and you are asked to add to hang 20 grams or 30 grams or whatever. But when you hang that, adjust this looped line, the thread on BP, adjust that thread to be on that line BP, the line leading from B to P. So if you adjust that, you see an angle formed. We're going to measure BO. So you call that point, you mark that point that the angle that the thread reached, and then you call that O. So you measure BO and also measure AO. Okay, that's AO. So you measure BO and measure AO. So let's use a ruler so that it would be here. So you see, you measure B to that point where the thread is, that's BO. Then you also measure AO this way from where A is to that point. Of course, you may not need the thread to be there, so you remove the thread, okay, and measure correctly so that you don't make mistakes. You see the measurement. It may be different depending on the weight, the mass you are asked to apply. But whatever mass you are asked to apply, adjust that line to be on this BP, measure BO, and also measure AO like this. And then tabulate, put that in a table of figures, because you're going to repeat this process as you keep adding other masses to the line. Now remember to always keep it at that center. So we're going to add another mass. In your exam, if you are starting with 20, you may be asked add another 20, that becomes 40. If you are starting with 50, you say add another 50, that becomes 100, or they can say add another 20 to the 50 and it becomes 70, whatever you are asked. But when you hang, make sure you adjust that looped line to be on line BP. See, mine is not really there, so I have to adjust it well to be on that line. Okay, so alright, so that's the point. Don't let this line, this loop wire be dangling like that, so make sure it is not shaky so that you avoid parallax error. So now we're going to mark the point where this angle is formed. Mark that point so that we can measure our BO, the second BO now. You know, I wrote the other one BO1. Now I'm going to write O2 here now. So when we're going to measure this time, we're going to measure BO2 and AO2. We record that also. Alright, so that's the procedure. It's just as simple as that. You go over and over again, repeating the process with the different masses you are asked to keep adding. Alright, so we are going to just add one more, and then, but I'm sure by now you understand the whole process, so you can carry it out alone. So add one more and see how much angle difference will be formed. So we add one more into the mass hanger, alright, and then adjust the loop. Once you add another mass, the loop will move, because you know the pulley C is free, it moves. So you adjust this looped string until it stays on the line BP. So basically that's why you drew that line BP, to help you maintain that, help you ensure that the mass is at the center. Okay, so you see it's aligned very properly. So like we did for the other two, we mark also. Remember, the first one was O1, the second was O2. Now this should be O3 by default. So you know, remember, we measure BO3 this time and also AO3. It's just a simple process like this. Once you're able to set up your apparatus clearly, you discover that everything is easy. So ensure you set it up well, and make sure that the line, the rope, does not rest on the board, so like you're going to be seeing in your instructions. All right, so if you set it up correctly like this, everything is going to work very fine. Remember, your lines have to be accurate for you to have correct reading. All right, so the question said measure, first ensure that M and M naught hang off the board, so we don't allow it to touch the board. And then we measure BO, and they call that Y. Measure BO, measure BO1, measure BO2, like that, but that's BO. And if call that Y, also measure AO, and then evaluate Y all over AO, and repeat the experiment for masses. Different masses could be 70, 90, 110, 130, or one case can be 20, 40, 60, 80, 100 respectively. But in each case, determine the corresponding values of Y, AO, and Y all over AO. Then tabulate your readings, plot a graph of Y all over AO on the vertical axis and M on the horizontal axis. Then you are to determine the slope S of the graph, which you should know how to plot a graph and determine the slope, and then state the precautions taken to ensure accurate results. Remember, the precautions are clear. Ensure that the masses M0 and M do not rest on the board, they stay off the board, and then you will have your accurate results. And other precautions, ensure to do everything accurately the way you see it in that video, so you can go back and play it all over again and again and again to make sure you understand. Remember, this is on resultant forces, so you can also read other areas of resultant forces to get clearer understanding and to be ready for the second part of the question. Remember to subscribe to this channel so that you get more enriching content and prepare well for your exams. Thank you. God bless you.